This video covers concepts dealing with user-defined methods. Programs can become large and hard for humans to read and understand. Decomposing a program into smaller, more manageable pieces can improve readability and make it easier to understand and maintain. Methods simplify programs by allowing for code reuse. If a code segment needs to be performed multiple times throughout the program, the code can be included in a method which can be called each time the code needs running. Methods also allow for modular development, the process of dividing a program into separate modules that can be developed and tested separately and then integrated into a single program. Methods also allow for incremental development, which is the process of writing, compiling, and testing small amounts of code, then incrementally going through the same process with a small amount more. There are two types of methods, void methods and value returning methods. A void method performs a task and then terminates. A frequently used void method is the printline method. A value returning method not only performs a task, but also sends a value back to the statement that called the method. A value returning method that we have used is the char@at method. An index is passed into the char@at method, and it returns the character at the specified index. A method includes a collection of statements that are grouped together and perform an operation. Methods must be defined with a header and a body. The method header appears at the beginning of the method and describes several important things about the method. This is where the method name is defined. The method body is a collection of statements that are executed when the method is called. The method header always follows the same syntax, and the method body is always blocked by curly braces. The method header must include modifiers, the return type, the method name, and parentheses. The body is made up of the statements that perform the given task of the method. The method modifier public defines the method so it is available outside the class, and the static modifier defines the method so it belongs to a class and not a specific object. The return type is either void or a data type. A return type of void is used when the method needs to perform a task and not return a value. A value returning method also performs a task and in addition returns a value. The data type of the returned value must be specified. A method name is a programmer-defined identifier. It is a good idea for the programmer to name the method so that it describes the task it performs. This makes the code self-documenting. Parentheses are required and either contain nothing or a list of parameters that are actually variable declarations capable of receiving argument values. The code in a method executes when the method is called. In Java, processing starts with the main method, so it is automatically called. All other methods must be executed by call statements. To execute the previously defined sayHello method, the method name sayHello with an empty argument list is written as a statement. Only the method name and argument list are used to call a method. No other modifiers or return types are included in the call statement. If a method is defined with parameters, then arguments can be sent to the method when it is called. In the example statements, hello is passed to the printline method and 0 is passed to the char@at method. A parameter must be defined in the method header in order for arguments to be passed to the method. The argument data type must correspond to the parameter data type. By using parameter variables in methods, the methods can be designed to process different data values. In this example, the method output value is called and a 3 is passed into the parameter value. Notice that value is defined as an int and a literal integer 3 is passed into value. In the body of the method, the println statement outputs the contents of the parameter value. So the value is 3 is output by the method call output value 3. Be careful when passing arguments to parameters. The data type of the argument needs to be compatible with the data type of the parameter. Java will implicitly convert smaller data types to larger data types. This is known as widening conversions. However, if a narrowing conversion is attempted, a compiler error will be generated. In the code example, num is a double, and the parameter value is defined as an int. Converting a double to an int requires a narrowing conversion. Therefore, this code will generate an error. The method call output difference passes a 5 into num1 and a 15 into num2. These are widening conversions, converting ints to doubles, so it is allowed and implicitly performed. It is important to note that arguments are passed into parameter variables in order. This method will output 5 minus 15 equals -10. In Java, all arguments are passed by value, which means that only a copy of an argument's value is passed into a parameter variable. A method's parameter variables are distinct from the arguments that are listed inside the parentheses in a method call. Arguments and parameters may or may not have the same name. If a parameter variable is modified inside a method, the original argument is left unchanged. An object reference variable does not hold a value, but instead a reference to where the object is in memory. When an object reference variable is passed as an argument, the reference to the object is passed into the method's parameter. In the example, city name references the string San Angelo in memory. So if city name is the argument, then the reference to San Angelo will be passed to the parameter. In this example, there are two string objects, university and city name. The method call to display school passes the address of university and city name into the parameters college and city, respectively. So when the println statement outputs college and city, it is outputting the strings referenced by university and city name because both sets of variables reference the same objects in memory. Strings are immutable objects, which mean they cannot be changed. In this example, first president and president both reference the string object George Washington. When the president equals Abraham Lincoln statement executes, a new string is created in memory and the variable president references it. A variable declared inside a method is local to that method and is not accessible outside the method. The variable scope is local to the method in which it is defined. Different methods can have variables with the same name because method variables are local variables and cannot be seen by other methods. A method's variables exist in memory only while the method is executing. When the method ends, the local variables and parameters are destroyed. Local variables are not automatically initialized to a default value. Data can be passed into methods through arguments into parameter variables. Data can be returned from a method to the statement that called the method. In the example code, num and 2.0 are passed into math.pow. This method is defined to return the first argument raised to the second argument power. So in the statement, double squared num equals math.pow, open paren num, comma 2.0, close paren, semicolon, squared num receives the return value from math.pow of 25.0. A value returning method must define the return data type in the method header. In the example product method, the return data type is int. Therefore, in the body of the method, the return result statement must return an integer as well. When the return statement is executed, it causes the method to end and sends the value in result back to the statement that called the method. In the example code, the method call passes the value of number 1 into num1 and the value of number 2 into num2. Therefore, num1 is initialized with a 10 and num2 is initialized to a 2. The body of the method creates an integer variable result and stores the product of num1 and num2 in the variable. Therefore, 20 is stored in result. The return result statement causes the method to terminate and sends the value 20 back to the calling statement, which then assigns the returned result of 20 to total. When a return statement is executed, a method returns to the calling statement. A void method can include a return statement with no return value. Adding a return value causes a compiler error. A value returning method must return only one value. Non-void methods can return primitive data types or object references. Sometimes it is convenient to write methods that validate data and then return true or false. The call to a method that returns a Boolean value can be embedded in an if statement. As you see in the example calling code, isReady returns true when the sensors are in a state needed to activate the heat coils. A return statement is required for a value returning method. Even though the code in A is logically correct, it generates a compiler error because the Java compiler can only see return statements after conditional expressions. To fix the problem, remove the if n less than 0 in A so that the return -1 can be reached independent of a conditional expression. In the method call to full name, the address of the string objects James and Smith are passed into fname and lname respectively. Inside the full name method, a new string object is created, and a reference to the newly created string James Smith is returned to student name. When methods include arrays as parameters, an array's reference is passed to the method. Because a reference to the array is passed to the method has access to the argument array's memory location and can therefore modify the contents of the array elements. A new array can be constructed by a method and the reference to the new array returned by a method. In this main method, after the first line executes, list1 references a newly created array of integers that is initialized to 1, 2, 3, 4, and 5. When the second statement executes, reverse is called and a reference to the list1 array is passed into the list parameter. In the reverse method, the first statement creates a new array the same size as the list array. It then uses a loop to copy the elements in the list array to the reversed array, one element at a time, in reverse order. At each iteration of the loop, it copies an element and then sets the list array element to 0. When the return reversed array statement executes, the reference to the newly created array is passed back to the calling statement, which assigns the reference to the list2 reference variable. Notice that after reverse executes, the original array, list1, has all zeros in it because it was modified by the reverse array. Perfect size arrays have a number of elements exactly equal to the capacity of the array. Perfect size arrays are used when the number of array elements is fixed by the context of the program and there will never be a need to add or remove elements. A perfect size array can be passed to a method using only the array reference variable. Because the array is full, the number of elements can be accessed through the length property of the array reference. In the sample code, the method call fill homework, 0 initializes the entire homework array with zeros. There is no need to pass the size of the array because it is assumed that the homework array is full and will not need to add or remove elements. In the same way, the method call fill exam, 100 initializes the entire exam array with 100s. An oversize array is an array where the number of elements used is less than or equal to the capacity of the array. Since the number of elements used is usually less than the array length, a separate integer variable is used to keep track of how many elements are currently in the array. Oversize arrays are needed when the number of elements in an array is not known in advance or when the number of elements stored varies over time. When oversize arrays are passed to a method, two parameters are needed: the array reference and the current size of the array. In the sample code, the method call to add element passes the reference to the to-do list into array ref, the current size of to-do list into current size, and the string study into addme. Because this is an oversize array, the current size of the array must be passed so that inside the method, the new element is added at the end of the last element. Methods can have the same name, but must differ in the number or types of parameters. These methods are known as overloaded methods. The compiler determines which method to call based on the arguments being passed into the method. In this example, there are two methods named max. You can see that one has two parameters of type int and the other has two parameters of type double. The compiler knows which overloaded method to call based on the argument data types. On the right, the first call to max passes in a and b, which are both integers. Therefore, the first max method is the one that is called. The second call to max calls the second max method because it is calling max with 2 double arguments. An important part of a program is its documentation, which is intended to be read by programmers who must maintain or interface with the program. Program documentation is also known as an API, which is Application Programming Interface. Javadoc is a tool that parses specially formatted multi-line comments to generate program documentation in HTML format. Javadoc comments begin with /*** and end with *// Javadoc comments should include an overall description and block tags in the form of @block tag and then text that follows. A Javadoc comment starts with /** and ends with *// This is different from block comment in Java. Javadoc generates documentation in HTML format. The description of the method should appear first, followed by the block tags. The block tags should be in the format of @block tag followed by the applicable information. The Javadoc specifications can be explored in further detail on Oracle's Java website.